Okay. Hello, everybody. So the first thing I want to do is to welcome Vishnu from Sterlite Tech in the group. I see Puneet here. Vishnu is a developer from Sterlite that is going to help us work on ODTN. He's just getting started, and he's starting to set up the working environment in his lab, and he's coming from Sterlite, who is interested in taking ODTN and hardening it and adding some features for production trials and deployments. So that's good, and I look forward to working with him and Puneet too, which we had already on the call for some time. Puneet, do you want to add any words?
Yeah, thanks, Andrea. Uh, yeah, so we have shared the initial round of our test lab details, right? And I think in next few calls we will discuss about the use case and the implementation what we are going to do in our lab. So we are excited to work closely with all the team members. Thank you. So,
Yeah, thanks, Puneet. Yes, I've seen the document. We will discuss it internally first, and then on next call we can have a little bit of an overview for everybody on the plan, test cases, and the plan activities that we're going to do together.
sure,
Thanks.
sure, Andrea. Thanks.
Okay. So from another element, I still encourage everybody to submit to the open networking call for proposals. With the work that you guys have been doing in relationship with ODTN, I know many of you are doing something in terms of like products or in terms of solutions that are built on ODTN or lessons learned. Anything really that can be of interest with to the community at ONF Connect, I encourage you to submit it, and then we will take a look at it and review it from the the team within ONF, which is composed by me, Ramon, and also Dominique here, who is on we are on the group that vets the submitted talks, and we'll pick the final ones for presentation at the conference. So please submit your proposals. I look forward to reviewing them. Okay, Dominique, anything to add?
No, no for the moment. Yes, I think it should be pretty open, and yes, do not hesitate to submit your proposal.
And if it just needs an account, it's the standard CFP submission. It doesn't need to be a full paper. It's just a title and an abstract discussing what you guys want to talk about, and depending on your work, it doesn't have to be a paper. It's not a conference paper. It's not a big like multi-page work. It's just a small abstract that encompasses your work and showcases what you want to present. Okay, so that's it. On the next order of business, I had a very productive discussion with the people from the GNPy team over at the Polytechnic of Turin, and also with Gert and Kevin from Juniper, and Gabriele from Cisco, which are working on the GNPy tool. I think we have a pretty good and detailed implementation plan to leverage GNPy to include optical impairments in path calculation within ONOS. We have a presentation which showcases a little bit of details of what we have done and what is GNPy and like what GNPy needs. Kevin, do you want to start, or less? I can maybe go with the overview, and then you can discuss a little bit of a few things about GNPy, and then I can take it back on for the final details of implementation. Would that work?
Yeah, that sounds good. If you give the setup, then I'll talk a little bit, and then we'll let you finish off on how you see it being rolled out.
Yeah, and I think we can also take care of the discussions that you sent, the points that you sent me via email. I think we can discuss them over the call. So the idea is that for you who don't know what GNPy is, that is an open source tool that encompasses. It's an optical source planning tool for optical networks. So it takes into account many details, which Kevin will go over later, and gives you a measurement of the quality of your service depending on the existing number of optical channels, optical paths, devices, fiber spans, and all of that. The idea and why we would like to use it in terms of ODTN is that we would like to use it to retrieve the best possible optical link between two endpoints, given the performance computed by the GNPy tool. So what we want to do is predict and validate the capability, but also understand appropriate settings for the different elements within the optical network. So what we would do is ONOS would receive the request and really use GNPy and a little wrapper on top, which I will talk about later, to compute the best path according to the network and offload the path computation to it. It will be about a real deployed network. And the workflow would be that ONOS receives the request, passes it to GNPy and or that third-party element. GNPy computes the quality of the path, the quality of any possible path between those two endpoints that are required for the connectivity, and also with the best predicted performance. Once that path is instantiated into the network, it's returned to ONOS, and then ONOS installs it within the network, given the parameters that GNPy picked in power and wavelength and different modulation and FEC and stuff like that. So the idea is that we can also know the expected performance of a new link that is incoming in the network, and this would be independent of this using an OLS controller or a more fully disaggregated network in phase 2.0 of ODTN. Kevin, I'll let you take it from here.
Okay, thank you. So I'm just to set context for people who are new to me. I'm not actually a GNPy developer. As Juniper, we help lead the project, and I'm best an interested user in the application. So I've been looking at this application for many years, but I'm not actually a coder. So the place that I started with is, in order to be able to make this effective in an ONOS application, the first thing that we really need to look at is what information is required by GNPy in order to be able to do the nonlinear simulation and predict the performance of the path. So I broke that down into three groups of information that GNPy needs. Firstly, it needs to understand the network that's present. That's mainly in terms of physical topology. So to do that, it needs to know the node names. It actually takes in today the node location as well, which it can use for plotting, but that's probably optional in the ONOS application. And within the network description that GNPy uses, there are basically three classes of sites within the network. There is a fused site, which is, think of that as a glass-through connection. There's no active optical function at that site. There's an ILA, which simply does amplification, but there's also ROADM sites, which also allow add drop of channels. Now we need to know how all of those node types and fibers are connected together in the network in a topology map. And then we need to know the information about each of the fibers that connect those nodes together. Now, GNPy today is specified in a unidirectional path. And typically we take in fiber distance in kilometers, the fiber loss in terms of dBs per kilometer, but also the fiber type. And using the fiber type, a number of different default characteristics are pulled in, specifically for chromatic dispersion of the link, but also for the nonlinear coefficient gamma of that fiber type, so the nonlinear modeling can be done correctly. We also have fiber input and output connector losses to make sure that we know the actual power in the fiber. And finally, we have the polarization mode dispersion. Now, for each node within the network, we need to look at what equipment is being used. And for the node, and that is for each degree or direction of the nodes within the network, we need to know the amplifier type. Now, there are currently a number of different amplifier types defined in GNPy, but it's relatively straightforward to provide an amplifier characteristic file which describes any other amplifier that we want to include. And these include the gain range of the amplifier, so the max and min gains, the output power limits of the amplifier, but also includes things such as the dynamic gain tilt characteristic of the amplifier, which describes what the change in spectral shape is as the amplifier tilts. We also have the gain ripple and the noise figure versus gain that we can use to predict the noise figure based upon not just a static value, but dynamically based upon the loading in the network as well, and how the amplifiers are set up to compensate for the losses. Now, also input and output losses of those amplifiers are accounted for, but we also need to know the gain settings and tilt settings within the amplifier, which can then run through that model to predict the spectral evolution of the signals through the network. If you could give me the next slide, please, Andrea. Thank you. And finally, the third group of information that we need for GNPy is really the service. And in GNPy, each service has a route ID number. We need to know where that's being sourced from, which ROADM node is entering the network, which ROADM node is leaving the network, and we need to know the transceiver type. And the transceiver type also has a characteristic set of information, which includes the frequency range, the programmability of that transceiver, but also any modes available on that transceiver. So what baud rate, what required OSNR, bit rate, shaping factor roll-off, things like this are all known in the transceiver characteristics. Now, going through the service, we need to know what the channel spacing is, so how close channels are related to that. But also, we need to know the system input power going into the system. Now, finally, GNPy currently can work out paths through the network, but you can also specify a specific path, which I think is how we'll look to use it with ONOS, where we specify to the simulation tool all of the ROADM nodes through which the path travels, and therefore we can calculate directly the OSNR of that path. Next one, please. So when we do that today, so GNPy is a Python application that's currently pulls in that data in a JSON format and then runs the simulation. And from that run, it returns the delivered OSNR of the link, and that can be represented in a number of different ways, either in the standard way of using the ASC referenced in a 0.1 nanometer bandwidth, but also, and this is something we should think about for the longer term, as we move towards variable baud rate transceivers, it will also return the OSNR based upon the ASC and the signal bandwidth, and that makes it a little easier to compare transmission paths where you have variable baud rate options that are being considered. Finally, it also delivers the SNR of the path, and the SNR is also includes the nonlinear impairments on the signal, and so the total SNR is based upon both the optical SNR but also the nonlinear impairment. So using this, we can specify a network, we can specify the equipment in the network, specify the path through the network, and then recover what the OSNR behavior is. Do you want to take over from there, Andrea?
Yeah, I can take that. Thanks, Kevin. It was a great introduction. So, really, the end goal for us would be to leverage ONOS to first learn about the network and feed that information to GNPy, meaning that ONOS is the source of that those details that Kevin presented before, then when ONOS receives a path request, it asks a wrapper to analyze every possible path within that network between point A and point B that it received, and that wrapper asks for each of those paths, possible paths, to GNPy to compute the quality level, the one over the OSNR for each of those paths. Then we pick the best one given that value and maybe a few other things, which we will discuss a little bit later. And then it communicates it back to ONOS, telling ONOS, hey, pick these devices given this wavelength and this set of configuration. And then ONOS installs that configuration into the network. So from this figure, if we look at it, there are a few missing pieces. The first one is that GNPy PCE wrapper that we did some investigation. And we found out that Orange has done some work in there, meaning that they did demo at TIP a work where they were able to compute the best path through GNPy with a set of Python files. So we would likely reuse that. Then we would need two APIs, one for the path interaction with the wrapper, and the other one for the topology data with GNPy itself. So those are the three things that are kind of missing at the moment to make the two talk to each other and achieve the end goal of using the GNPy and this wrapper to offload the path computation from ONOS itself. So in the first phase, what I discussed with Polytechnic of Turin, Gert, and others is that we would look at pushing the network information with an existing JSON format or Excel file and do it exactly as GNPy does it at the moment without having to change that. Meaning, so that does not impact what we do at the moment with the existing GNPy, and does not impact ONOS, that we don't need to add another API to ONOS itself. Can you guys still hear me?
Yep.
Okay, perfect. Thanks. But then we still need the API 3 and the pieces 3 and 4, meaning that there needs to be a REST API or some form of API between ONOS and that wrapper, and to request the path and retrieve the path. Meaning that at the moment I've seen this working in a terminal through command line. We just probably need to extend that to make a file with the REST API interaction to provide that information to of the connection request to GNPy wrapper and retrieve the connection from it. So this is the first phase. Obviously, in the second phase, we would go and then actually do the information about the topology from ONOS to GNPy without having to manually input it, and that's probably going to be through TAPI because it probably exposes the required parameters from an optical layer. I think we came to discuss these two phases of integration because the first step is to see that it's possible to use it and provide a proof of concept, and learning the network information, since it's a static element, it's something that can be done once and doesn't need to change at a faster pace as is the different optical paths. So the more interesting component is to actually use it as a path computation element, but not learning the topology. Topology is a second step. So with phase 1, we will reuse this PC wrapper that Orange has done, probably extending it. I have a discussion with Guliam from Orange itself in upcoming week to see what that is done, and I will include everybody on the details of that. And then we will work on the API for the paths on phase 1, and then on phase 2, we would probably take it over and do the final end-to-end integration with the topology data being forwarded from ONOS to GNPy. We discussed this. This is the opportunity that what we're gonna do. So the next step is start extending the path computation with the REST API and showcase some of this work at the ONF Connect, ECOC, and TIP Summit at the different booths between ONF and TIP that we have, and submit a paper to ECOC 2020 showcasing this as a possible work. I borrowed this from you, Kevin.
No problem.
Any questions? No? If not, I'd like to bring up what Kevin was saying before.
I
Sure.
may have a small question, maybe because this is about the PC wrapper that you intend to use between GNPy and ONOS. Can you just brief me a little bit more on what is this PC? Is it based on the PC protocol, this wrapper, or what is?
So no, I call it just PC wrapper because it does it's a path computation element. But what really does is that since GNPy has no notion of iterating over the path, what that component does is basically iterate over all the possible paths between A and B, or on the network that it knows about, and according to some parameters, a certain wavelength, a certain power output, certain OSNR, and like does the optimal computation for that for any given path between A and B, and then picks the best path according to the measurement that GNPy did. Does that make sense, Dominique?
Yeah, you clarify a little bit, yes. Okay. Mm-hmm.
So the idea is really that you give it point A to point B, and that looks at the network and picks the different devices between point A and point B, and goes over all the available wavelengths that these devices support, and the different power levels that they can achieve, and the different like fiber spans that they have in the middle, computes the quality of the path according to the GNPy measurement, and after that we retrieve all these quality measurements and we pick the best one. This gives me a proper segue to what to the email Kevin sent me, which actually brings in a good point that we might also want to consider not just the OSNR as the constraint, but also the latency and the path length. I did think this is a good idea. Kevin, do you want to say a few comments on this?
Yeah, and just to add to your comments a moment ago, the way I think about the division is that GNPy is very much focused as the physical simulator that says this is the performance that we should expect on any given path. But the PCE wrapper, I believe, should be where the decision-making intelligence is made in terms of which routes to test in GNPy, but then also which ones to select for implementation in the deployed network via ONOS. So, the question I raised in this email was basically saying, well, whilst I think all of us start with OSNR as going to be the mechanism by which we would tend to optimize the network, because that's usually going to allow you the highest transport bit rate on any given link. There are potentially other constraints that we may wish to bring in, and the one that's most often talked about is latency of a path. Whether that's length or latency directly, but also that there can be other constraints as well, such as spectral occupancy, in order to manage fragmentation of the network as the deployed capacity grows. So there are basically two paths you can go to consider how to optimize that. And one is to allow that decision making to be done by the PCE wrapper to prioritize and filter the paths that are being modeled by GNPy, and then use that decision based on, well, I've only given it paths which can meet my latency requirement, and I'll calculate from them. That's probably good from a calculation efficiency point of view. The alternate approach is for the PCE to say, well, actually, I can see all these different potential paths through the network. Give me all of those paths, and then tell me what you've got in return in terms of latency, as well as OSNR and everything else of those paths from the PCE, from GNPy. And then the PCE does the multivariable decision process to say, okay, I'm going to rank them in this order. I'm going to try and take the first one. If that's available, I'll take it. So really, I just wanted to raise that we might want to consider, rather than just a simple OSNR optimization, that we actually look to build a solution which is at least scalable to multivariate optimization, because I think this will be required in the future, even if we only start out with the initial implementation by actually using OSNR.
Yeah, I fully agree with that. I'll make sure to add these comments to the slide deck so we keep track of them, and we make sure that the implementation goes accordingly. My preference would be that to pick the second option, meaning that we calculate the richest set possible and then filter, because filtering beforehand might be more difficult, at least in from my point of view.
Yes, it's certainly. I think the option one puts more of the decision making and stress onto the PCE wrapper, and like you say, it then may need to have more information. The second one is probably computationally more expensive, but potentially has less chance of missing a good option.
Yeah, and at least for what I understand, this being not this being still a lot less computationally heavy than and time consuming than existing solutions, I think it's still okay computing a lot of data and then picking the best one. Also because after you compute a lot of data is data that you can probably store and reuse. And this is all optimization, I think, and might come at a later point in time. But I think that for a start, this is a good start.
Yep.
Okay, and again, as I said, the goal is to submit something, to have something running, at least a first example with at ONF Connect ECOC and TIP Summit. I'm going to start discussing with also Vittorio from Polytechnic of Turin with some of his students that were interested in contributing to this. So this is great. I think it's a very good element. Any other questions? Okay, if not, for the people online, please do share your thoughts whenever you can via email, or if you want to go through again the presentation and read through it and see what's what. I encourage you to do that and provide more comments in the upcoming future.
So Andrea, just one question before we hang up.
Sure.
So I mean, I can understand the GNPy are trying to do like the single path computation. When it's a single path, I mean, it defines the two endpoints, and you're going to do a path computation of what the physical layer is going to look like. But the layer above that is, okay, if I've got a node size that is fairly large, and the combinatorics of possibilities are fairly enormous. What layer does the ONOS layer handle that portion of it? Basically say, hey, wait a minute, I've got, say, a 300 node network, and I need to find an optimal path between 2 points. But the optimal path between 2 points in terms of combinations are enormous. And how do you filter that combination before you give it to your path computation engine?
Thanks, Raj. That's a very good point, actually. I did not think of that in depth, but yeah, I would expect ONOS to filter out if we're talking a very big network, to filter out the request to the PCE wrapper, or the PCE wrapper itself to filter out before requesting the path computation.
Yeah, and that's effectively what I was trying to suggest with the option one, that if you have known constraints, whether they're things like latency or length that you want to apply, just to pre-filter that list, and then you can see which of the remaining paths have the best OSNR. But also we could potentially also use simple techniques such as number of node hops to prioritize the list that's being sent to the GNPy in order to try and manage that computation somewhat. Because I agree, in a large mesh network, that could become untenable.
Thanks for the point. I'll make sure to add this to the presentation too, that at some point we need to do the filtering of the request. It's either, again, a decision on where you put the intelligence between the two components, either in ONOS, either in the PCE wrapper. The knowledge of the topology is present in both, so I believe we can do it in both places and have a suggested path or a suggested subset of devices to be given to the PC from ONOS, or the PC compute this subset of devices. It's really up to the implementation details. I'm fine with both, with either, so it's a good point. Thanks for taking care of this, Raj. And I think this holds true for many different type of devices that we want to consider, independent of transponder, open line system, ROADM, fully disaggregated, partially disaggregated networks. I think this holds true for all of them. Just put a note to myself here to do that. Whatever. Okay. Then, thanks to the discussion we had the last few times, we did have an agreement on the power configuration workflow that is presented in this slide, if it comes to life. Slide over here. The only problem that I've been seeing with this particular workflow is that OpenConfig does not provide knowledge or information about a minimum receiving power, meaning required input power on the receiving side. So I am a little bit in doubt on how to proceed regarding this point, because one option is that we already know the power target from, let's say, the component, meaning that the component has a fixed power range it can work at, and we provision that information into ONOS via this when the device is discovered. Or well, I don't actually see another alternative. But that means that we have to know at which power range the, let's say, the ACO card or in general, the transceiver can work. Any comments?
No, I think that's true. I think the only general comment I would place is I think increasingly we need to start thinking about whether the devices can communicate their requirements and specifications back to the controller so that we can make smart decisions. Probably doesn't just apply to power in this case, but things like required OSNR and other things going forward.
Yeah, I agree. So I would say that for now, I will, for example, try and see with the different vendors if they can tell me like what's the power, the dBs, the minimum dBs and the maximum dBs the unit can work at. For example, Dominique, if let's say I take the Nokia transponder, uh, do we know at which power, the power range the transceiver can work at, uh, or is that an information that we cannot know and it's dynamic?
I need to check. For sure we can know it because we have through its we have a web interface that we use to know it. But to report this information to, I think it's possible. But let me confirm that. Let me to check internally to tell you how it is done.
I mean, and again, as I was saying before, if it's a fixed information, like I don't know, the running temperature. This device has to run between -10 and +30 degrees. Though that is the temperature, the working temperature of any given device. I don't know, something like that. If the power is the same, it can be provisioned in ONOS during the learning and can be somewhat hard coded into the implementation, so we know. I think that's definitely an option if it doesn't change, given multiple optical channels, for example.
Quick comment from my side, Stefan here. I think it will also depend on the modulation scheme. So like a QPSK might have different values relative to 16 QAM, right? So it might be a table, that everybody will somehow communicate a table of different values.
And
it might not only be a single value.
Yeah, to add to that, Stefan, I think it's potentially not just with modulation format, but also as we look to variable baud rate transceivers as well, that may well vary with baud rate too.
Right. Yep.
So it's certainly a matrix.
Yeah, right.
Oh, okay, but even giving all these changes based on baud rate and on modulation, you could still know this. Okay, if we pick QPSK with a given baud rate, it has to be at least 3 dBs and no more than 9. Does that still hold true?
I think in most cases, what we would tend to have is specified static ranges for each of those operating modes, if you like. Certainly, that's my experience. You know, they could be coded in as, if you like, datasheet values into ONOS. But I think looking to the longer term open networking future, I think the opportunity to have the device report that to the controller for its specific version and instance is probably a much more flexible way in the future. But clearly, we've got a long way to get there.
I mean, we have a pretty good relationship with the open config standards people, and this is something that we can definitely propose to them and see if they are willing to extend the open config standard to include this parameter, this operational data of the device. Really, would you guys think that would be of value if we reach out to them?
Yes, I think so.
Okay. Yeah, then I can do that. I'll also talk to Arturo, which has dealt with the people from OpenConfig before, and do some research and see if we can capture this. But in the meantime, we can still provide this matrix in ONOS via coded as data sheets, basically. Okay. then the workflow goes on. I think this is fine from that point onwards. I think we're good. We have all the data we need then to do this computation and provide the path. I know Buyan will also work on this, and he has already started a patch for the OpenConfig devices to do get and set of the target output power. Buyan, do you want to comment on that patch?
Sure. I want to describe my patch. It's very simple actually. The things dispatched. Oh, thank you, Kenji. All right. As you see, there's the important class is Cassini terminal device power config. And in this class, we implement two basic functions. The first one is a get operation from the terminal device about the power config target output power config. And the second thing is to extract to cite the target output power config to the Cassini determined device. All these operations are defined in the OpenConfig terminal device YARN files. Okay, sure. We can see that. Yeah, there's two functions: the get target power and set target power. Yeah, these two functions implements the functions I mentioned above.
Thanks for that. And just to mention, we call this the Cassini terminal device power config because we have tested it with the models we have used on the Cassini device. But I expect this to be no different in any other OpenConfig compliant hardware. For example, the Nokia one should be straightforward to use this. And thanks to Boolean, we also have a command that we can test this with. It's just a CLI command to test the set and get of the power, and this will also be included thanks to the work that Wataru and Shrikant are doing. Will be included in TIE, the transponder abstraction interface for the different ACO DCO cards that is provided inside the TIP OPT group. So this is the patch for the start of the configuration for the transponder. Now we're going to work on integrating this workflow with sorry, not this one, with the open line system, with the people from ADVA and others who have a TAPI interface. I'm also talking with Dominique about the Nokia implementation. And the idea is that, again, we're going to request the path and then have a negotiation about the power configuration, and then have the workflow done and implemented in the code in order to be able to create the power optimization as an end-to-end component. That's about it, I think. Any other comments? No? Okay. If anybody has any other thoughts at a later point in time, please feel free to ping me or Buyan, who's also working on this, to continue the discussion that we're having. Okay. Okay. I will add implementation stories to Jira in order for me to be capable of assigning these things to people and making sure that we track the work that is being done. Is there anybody that can give us an update on the TAPI status? Okay. Then if not, I hold through this information and I think the TAPI group is still targeting May 10th as their C2 date. I have not seen anything strange from my point of view in the latest release candidate that you guys have. So if it stays as is, I think it's good from our side. Okay, just let me go back to Jira. Now, just taking a look at the Jira stories, there's not much of an update in here from last week. I need to update them with the power configuration issues and stuff like that. The only thing that I know is being worked on is augmenting and extending the Lumentum drivers with the optical connectivity intent. I know Alessio has a patch. Unfortunately, well, Easter got in the way and he couldn't upload it, but he's going to upload it in the upcoming days to make sure that the Lumentum RODUM 20 work with the optical connectivity intent that we're using and basically achieving the same objective of tuning those devices individually through input and output power. At the same time, Alessio and Ramon are also working on making sure that the bidirectionality that we are assuming still holds true by picking two different ports on those RODUMs. Usually the input is the 1 and the output is the 2. So if we want a bidirectional intent, we actually have to set up two intents with the two different ports, one for input and the other one for output, in order to achieve the end-to-end path in both directions. That's about it on my side. The last thing, any questions? Okay. If not, last a little bit of an update on the next generation ONOS configuration, which we're going to use in ODTN. We're still going forward. There's been great work done from Sean, and the repo is updated to see this work in a branch. If you guys are interested in the next gen config stuff, please tune in the upcoming hour from 6 to 7 Central European time, 9 to 10 Pacific, to see, 9 to 10 Pacific, to see a whole ONOS TST about it, to learn more information. Any other topics that anybody wants to bring up? No? Okay. Then if not, I'll talk to everybody next, actually no, next week I am on personal time off. I'm going to see if somebody wants to hold this meeting. I'll ping a few people and see if they want to chair it and discuss a few things between themselves, between you guys, to further discuss the different implementation and work that you guys have been doing. If we deem that that's not an option, I'll reschedule it in 2 weeks from now. Okay?
Okay, perfect. Sounds good.
Okay.
Thanks, everybody. And I'll follow up with on email on the different things that we have discussed to make sure that we include them in the different workflows and operations that need to happen. Thanks, everybody. Take care. Bye-bye.
Thanks. Bye.
Okay.
Thanks.
Thank you,
Thanks, bye.
Andrea and Ola.
Thank you.